Welcome. In this video, we are going to start the testing of hypothesis by doing some problems. So, first of all, let us see the procedure to test the hypothesis. First, the thing is that we need to define the null hypothesis, and depending on the nature of the problem, we can choose a one-tiled or two-tiled alternative. Okay. When it comes to problem, I will explain you what do we mean by one-tiled and two-tiled. Okay. Using the significance level alpha, the critical region is identified, and with the help of the sample data, we can compute the test statistic, whether it is following a standard normal or a t. That also depends on the sample size. Okay, and the null hypothesis is rejected or accepted according as to whether a test statistic falls into the critical region or not. Okay, we have something called p value of the test, and that is what we are going to, when we perform a problem, we will understand what it is. Okay, now we will see a test concerning mu. So basically the alternate hypothesis is to test whether mu equals mu naught at a significance level alpha. Suppose our sample size is large. So in that case, we of course we are going to make use of standard normal distribution, and the test statistic would be x bar minus mu naught upon sigma upon under root n. If population variance is known. If the population variance is unknown, we can very well make use of the sample variance. Okay, sample variance to calculate the standard deviation for the sample, and we just use with it. Okay, and the critical region is as follows. Now that our null hypothesis is simply mu equals mu naught, but we are not very sure that what is our alternate hypothesis. So this leads to, we can simply say mu is not equal to mu naught. Okay, but we may have our own alternate hypothesis. It is not necessary that one should always check for this mu not equals mu naught. Okay, so that is why we have three different cases, that is mu is bigger than mu naught, and mu is smaller than mu naught, and mu is not same as that of mu naught. So these three are the possible alternatives. Okay, based on the researcher or based on the person who is testing these hypotheses are free to decide their own alternative hypothesis. Okay, so after fixing the hypothesis, when are we going to reject? Because the all the test and the experiment, the sampling, and every of these calculations are carried out to reject null hypothesis, because null hypothesis has nothing to prove. Okay, only when we try to reject the null hypothesis we come to some conclusion, because alternate hypothesis is the one that we decided. Okay, so when are we going to reject null hypothesis? For if this is the alternate hypothesis, that is mu is bigger than mu naught, we check if the test statistic z, that is what we calculate, whether this is bigger than the table value. Here the z alpha, z alpha upon 2 are the table values, and z is the value that we calculate with the sample. Okay, and this is read from the table just by, with the help of that significance level alpha, we just take it from the table. Okay, so if this is the case, these are the conditions. So with these conditions we are going to see the things. Okay, and this is standard normal table that we will make use of, and these are some fixed values, like these are the most frequent values that we will use in the testing the hypothesis. That is why it is given separately here. Okay, now we move on to a problem. Here the problem is considering about a truck firm who is concerned about the average lifetime of a certain tires. Okay, the firm puts 40 of these tires. Remember, here n value is 40, which is considered as a large sample, on its trucks, and gets a mean lifetime of 27,463 kilometers with a standard deviation of 1,348 kilometers at a level of significance alpha equals 0.01. Now we need to test the null hypothesis that the true mean life of such tires is 28,000 kilometers. So basically Our null hypothesis is mu equals 28,000 against the alternate hypothesis that it is less than 28,000 kilometers. So from the given input, what we have come to know is that n is 40 here and x bar is 27,463. Okay, and standard deviation is 1348 and alpha is given as 0.01, and our null hypothesis is to test mu equals 28,000 against the alternate hypothesis that h1 is mu is smaller than 28,000. So from the question and the given information, we have framed out everything now. Now, what is our test statistic? So, test statistic is our z value. Okay, that is x bar minus mu divided by s upon under root n. Okay, so sorry, I have made a mistake. It is not the sigma, it is s, because it is the standard deviation of the sample, not the entire population. So it is 27,463 and mu value is 28,000 divided by s is 1348 divided by under root 40, and when you calculate you get minus 2.52. Okay, now we will see what is z alpha. So it is now that we have mu is smaller than mu naught. So when mu smaller than mu naught, this is the case, we'll have to calculate minus z alpha. And alpha is what? 0.01. And for 0.01 we have this value 2.33. So therefore minus z alpha is minus 2.33. Now we have our z value as well as z alpha value. Let us compare these two values. Which one is bigger now? So it is very evident that our z alpha is a bigger value, right? So the calculated test statistic is smaller than the uh, table value. Therefore, now what should we do? Here z is smaller than z alpha. Checking the condition, if z is smaller than minus z alpha, we reject null hypothesis. Okay. So therefore, we reject h naught, and hence the average lifetime of the hence the average lifetime of tires is less than 28,000 kilometers. Okay, moving further, the next problem states that a test performed with a random sample of 40 diesel engines. Again, here it is a large sample, that so we will make use of standard normal produced by a large manufacturer show that they have a mean thermal efficiency of 31.4%. So mu value is 31.4 with the standard deviation of 1.6. Sorry, it is not mu, it is the x bar value. So it is the value that is calculated with the help of a sample, and this is a sample standard deviation. At the 0.01 level of significance, we are about to test the null hypothesis mu is 32.3 against the alternate hypothesis it is not. Okay, now let us set up the problem with mathematical notations. N is 40, x bar is 31.4 percentage, and s is 1.6 percentage. Since we don't know the actual population variance, we use this value in the calculation. Okay, and alpha is 0.01 and h naught is what? It is mu is 32.3 percentage, And what is the alternate hypothesis? That is mu not equals 32.3 percentage. Okay. And now, when should we reject the null hypothesis? In this case, so now our case is that mu is not equal to. In this case, if either this or this happens, so as a cumulative thing, we can take absolute of z is bigger than z alpha upon 2. So the null hypothesis is rejected if absolute of z bigger than z alpha upon 2. Okay. Now let us calculate the z values. Z value is what? X bar minus mu upon s upon under root n. Isn't it? So it is 31.4 minus 32.3 divided by s value is 1.6 upon under root 40. Okay. When you perform the calculation, you get minus 3.557. And what is z? Alpha upon 2. Alpha is 0.01, so it is 0.005. So this value we will have to read from the table. So z 0.005 is 2.575. Okay, 2.575. Here absolute of z is bigger than z alpha upon 2, and hence we can very well reject alternate null hypothesis. Okay, so with which we can say that the mean thermal efficiency of the test is not 32.3 percentage. Okay, so that's it when the case of a large sample. In the upcoming video we will discuss about the small samples. Thank you.